Hello, my name is Ghilea Maria Raluca and I study at Colegiul Național Calistrat Hogaș Piatra Neamț, Romania. The topic of my presentation is colder than absolute zero. Absolute zero is often thought to be the coldest temperature possible, but now scientists show that they can achieve even lower temperatures for a strange realm of negative temperatures. First of all, let us define the notion of temperature. An object's temperature is a measure of how much its atoms move. The colder the object is, the slower its atoms are. At the physically impossible to reach temperature of 0 Kelvin or minus 273.15 degrees Celsius, atoms would supposedly stop moving. As such, nothing can be colder than absolute zero on the Kelvin scale. Still, some researchers claim to have recently achieved the first negative absolute temperature. So how is that possible? By cooling atoms in a vacuum chamber and using laser beams and magnetic fields to precisely control how these atoms behaved, they have actually managed to obtain a temperature of negative nanokelvin. What's really interesting about this discovery is the implications it has on other areas of study. One important consequence of negative temperatures has to do with entropy, which is a measure of how disorderly a system is. When objects with positive temperature release energy, they increase the entropy of things around them, making them behave more chaotically. However, when objects with negative temperature release energy, they can actually absorb entropy. This would prove extremely useful in creating new heat engines that would be more than 100% efficient, something seemingly impossible. Such engines would essentially not only absorb energy from hotter substances, but also colder ones. As such, the work the engine performed could be larger than the energy taken from the hotter substance alone. Negative temperatures might also help shed light on some of the greatest mysteries in science. Scientists had expected the gravitational pull of matter to slow down the universe's expansion after the Big Bang, eventually bringing it to a dead stop or even reversing it for a so-called Big Crunch. However, the universe's expansion is apparently speeding up. Accelerated growth that cosmologists suggest may be due to dark energy, an as yet unknown substance that could make up more than 70% of the cosmos. In much the same way, the negative pressure of the cold gas that researchers created should make it collapse, but the negative temperature keeps it from doing so. As such, negative temperatures might have interesting parallels with dark energy that may help scientists understand this enigma. As bizarre as they may seem, negative temperatures might actually hold the key to some of the greatest mysteries in science.